All right, let's get a full screen here. Come on, there we go. All right, so these are the problems that we're going to get after in a little bit. Just some sine and cosine evaluations, cosine and sine evaluations. I like to start saying cosine first because it's really an XY orientation. More about that in future videos. In order to do those problems, it'd be helpful if you've already looked at what is a radian and introduction to the unit circle videos or somebody else's introduction to this material. Doesn't have to be mine, but you want to be looking at those concepts. We're going to be primarily looking at the language of trigonometry by using the 30, 60, 90 triangles, the 45, same thing here, 60 degrees, so it's a 30, 60, 90. And becoming familiar with these ratios and where they come from. Introduction to the unit circle spells that out. Not going to do that here. We're just going to get the practice in, assuming that you've already considered some of these concepts. I have put up some decimal approximations for root 2 over 2.71, root 3 over 2.87. It's helpful to have a feeling for size. Square root of a half, right, is a half. Square root of 2 over 2, square root of 3 over 2, square root of 4 over 2, so on and so forth. Those are the numbers we can work with without a calculator. For instance, if I were to multiply this, the ratios in the 30, 60, 90 degree triangle here, if I multiply everything by 10, this would become 10, this would become 5, this would become 5 root 3. Right, and the ratios are the same. The smaller side to the hypotenuse still a 1/2 to 1. The adjacent side to the hypotenuse is still a root 3 over 2 to 1 ratio. You can spend some time with that. So we want to become familiar with these ratios in order to be able to do the problems that I've listed on the left. All right, I tried to get a good graph of a circle off of the internet, and for whatever reason, I can't seem to manipulate the technology to make that happen. So I tried to make a circle, and I was pretty pleased with my first effort. Considering my rotator cuff problems, that's not too bad. So we're going to go with it. If you go back a little bit in the video, you'll see that the 30, 60, 90s deal with 1/2 and root 3 over 2. So I put some dots saying that this is a unit circle, maximum height 1, maximum width 1, minimum height -1, minimum width -1. All right, so I put the halfway points there because that's really going to help us with the 30, 60, 90s and the 60, 30, 90 problems. All right, so again, good drawings are going to get good answers. So I'm going to keep this circle up because it's about as good as I can do freehand. Angles to ratio is what we're looking at. And angles can be written as arc lengths on the circumference of a circle. And so pi over 3 matches up with a 60-degree reference angle. The pi over 4 is our 45-degree reference angles. And the pi over 6 are 30-degree reference angles. And you have to give these things repetitive consideration if you're going to have it become part of your foundational expertise. All right, so what's the first one we're going to try? Let's see if I can get all of this captured. All right, so we're going to tackle the cosine of pi over 3. I think you can see that. When I look at it, it's written backwards. Oh, that's interesting. All right, so the cosine of pi over 3. We have a pi over 3, a 60-degree reference angle, which means I am going to draw, let's see if I can do this well. All right, let's keep the x-axis there. All right, and I'm going to break this up into 3 parts, and these 1/2s are going to help me. So actually, a good drawing would be that. That's a 90-degree, and over here, that would be 120 degrees, but we're after 1 pi over 3, which is this distance. And pi over 3 is approximately, 3 goes into 3.14, about 1.05, I believe. Pi over 4, I believe 0.78 is close enough. And pi over 6, I think 0.52. These are radius lengths. Right? And this is exact. These are approximations. So pi over 3, 60 degrees, a little bit more than 1 length. And this is a radius. So if I attached it there, I am talking about the video, what is a radian? All right, you go look at that. All right, so these are my 1/2 √3/2 1 ratios. And I can see that the pi/3 is the adjacent side divided by the, oh, I want to keep that there, divided by the hypotenuse. And I can see that that is, just going to leave a little mark there, 1/2. All right, so now I got to erase that one. Try to keep my halves there because I think they're going to help me get good drawings for you. And good drawings get good ratios. So that's not too bad. Let's keep this going. And this is where my origin is. I thought it was halfway. Doing the best I can here. Next one. 2 pi/3. Well, we had that just a minute ago, right? So I break up pi is 180. I break it up into 3 parts. I bring the altitude down to the x-axis, and I got myself a good 60-degree angle, or 2 pi/3. Radius length takes me to here, acts like an angle, and it looks like I got √3/2 for this side. That's the bigger side, 0.87. -1/2, 1, but I'm looking for the sine, which is the opposite over hypotenuse, so that's √3/2. Okay, more practice coming your way to a theater near you. Right? I don't want to lose that nice drawing of the circle, so we're going to use the old eraser. Now we're looking at -10 pi/3. Whoa! Well, pi/3 are the 60-degree critters, right? So that's going to continue here, continue there. So there's 6 parts to the circle, and each one is a 60-degree angle. Well, I can get rid of that. Okay. And I'm going back 10, which means that, pretty soon you're going to go back in this direction, minus 6 pi/3, right? So that's -2. So then I got, but I'll count them for you. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10 pi/3 is a triangle drawn right there. Same triangle we had a little while ago, but this time we're looking for the cosine. The cosine is that length. And in the 30, 60, 90s, the smallest length is the half, but this is the origin. This is the origin. So the x value is -1/2, and that's the answer to this one. Okay, let's do another one, just like the other one. Sounds like some cheer out of a basketball game I remember in high school. All right. Can't remember what it's to, but that's okay. What's the radian measurement? 29 pi/6. I'm going to take the shortcut and say that 29 pi/6 is pretty darn close to 30 pi/6, which is 5 pi. And pi is halfway around the circle. There's 1. There's 2. There's 3, which is odd. There's 4, which is even. 5 pi, appears to be right there. And I didn't go quite that far. I went 29, and 29 pi/6 is a 30-degree reference angle. I think my triangle looks like that because there's 1 chunk of 6, 2 chunks of 6, 3 is straight up. There's 4. There's 5, there's 6. I'm 1 shy of 5 pi. And what's the smallest side? 1/2. What's the width? -√3/2. I'm looking for the sine, which is opposite over hypotenuse. I think it's in the unit circle, the height. There's 1/2. Now we're going to try 15 pi/4. Got to get rid of my slices, and we're going to start jumping around the circle here quicker and quicker and quicker as we get familiar with the jumps. 15 pi/4. I think that's close to 16 pi/4, which is 4 pi, 1 pi, 2 pi, 3 pi, 4 pi. Shout out to Lawrence Welk. But we want 15, which means that we're gonna be chunks of 4, it's about halfway around the arc. My guess is that's where we're at. 16 pi, so that's 1, that's root 2 over 2. This is also root 2 over 2. They should be the same length. And I am looking, but negative, excuse me. Almost getting through the video without making a mistake. Made a momentary one there, corrected. Oh, let's get rid of this. We're not looking at that triangle. We're looking at that triangle. And so what is the cosine of 15 pi over 4? It's the width. I'm hoping that looks like it's about 0.71 units long. And our answer, our exact answer is root 2 over 2. Let's practice another one. See if you're getting the hang of this yet. Next one. And I hope that by the end of the term, you can look at this and go, oh, I know that answer. Do I? I think it's going to be minus root 2 over 2. Am I right? No, 28 pi over 4. Minus 28, 7. Oh, I would have been here. Minus 28, 7 pi. And I want one more in that direction. And I want the sign. I think it's going to be root 2 over 2, but let's take more time because my brain's tired right now. I've been doing this quite a bit today. Let's find out what it is. Let's break it up into 4 parts. 1. Oops, I gotta be careful. Halfway. 4, 5. Oops, butchered that one. 4, 5, 6, 7, whatever. 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, my brain is getting tired. So all the way around is minus 8 pi over 4, right? Which means minus 16 pi over 4. Multiples of 4. Minus, where am I trying to get to? 29. Why don't we cut to minus 28 pi over 4? Which is minus 7 pi. Which is right here. And one more makes minus 29. So yes, that is the triangle I'm looking at. And it's a 45-degree reference angle, which means that I have root 2 over 2 and negative root 2 over 2. And which one did I want? I wanted the sign. So the sign is positive root 2 over 2. And we want to be able to graph the sine and cosine functions and plot these little snapshots. But right now we're just practicing one skill, which will build into more skills. And hopefully enough skill that you get a bit of a foundation in this discipline. All right, there we go. All right, my unit circle is starting to get destroyed. Let's get rid of this. All right, what's the next one? The cosine of minus 5 pi. Well, we know that's here. All right, can't draw the triangle. But we've been looking at the cosine enough that I hope you know it's this width. And that width is negative 1. And just to show you the cosine curve, starting at 0 and going to 2 pi, where is it negative 1? Halfway, half a revolution, which is on this side of the circle. All right, so that one's done. Let's get rid of that. Okay, can I make it? Can I make it? I hope I can make it through this. Let's get rid of that. Let's find the sine of 47 pi over 2, which is pretty close to 48 pi over 2, which is pretty close to 24 pi, which is even, which is over here. And I want to be 1 less than 48. So I think I'm here. I think I'm here. And I think the sine is actually negative 1. But let's do it out a little more carefully. Pi over 2. Okay, well, that's pi cut into 2 parts. So we're looking at 90-degree angles, which is pretty hard to draw the triangles. And so therefore, 4 pi over 2 is once around, and 48 pi over 2 is 24 pi. I think I said all of this before. That's even, so that's true, that's there. And we want to be what? 1 less. So yes, we're straight down. Can't really draw the triangle. It has height. It's got no width. It's down 1. Hypotenuse is 1. So the opposite side to the hypotenuse is negative 1. I think you can see all of this. God, I hope so. I'm not doing this again. All right, so that was this. Cosine of 59 pi over 6. Okay, can you guess what we're looking for? Multiples of 6, right? I hope 60 pi over 6 pops into your head, which is 10 pi, which is on this side. And now we want what? We want 59 pi over 6. And remember, we're traveling counterclockwise. And if we undo the circumference, it becomes our angle axis. Angle axis, and we get these things called sinusoids. And we're somewhere down the end there. And we're looking at chunks of 6, which are 30-degree chunks. Where's my half? Oh, God. So halfway down, I think I probably erased it. So if I want a good answer, I'm looking for the halfway mark. Halfway, I'm going to put it right there. And the sign is an altitude. So halfway appears to be over here. And I should get a pretty decent triangle. What's the smallest side? Definitely the height. And what is that height? Minus 1/2. And that's what we're trying to learn how to do. And then we, of course, build off of that with, more difficulty in terms of what we're going to be looking at. We're going to graph these. And so we got to get a feeling for some values. If you don't have the feeling of some values of the algorithm you're working with, it's pretty hard to graph. Okay, so much for that one. Getting tired here. I don't know if I'll do another video today or not. Certainly going to take a break. Let's get that eyesight. Come on. There we go. End the video.